Hello. In this video, we are going to calculate delta G naught of reaction and the equilibrium constant K for the reaction carbon in the form of diamond going to carbon in the form of graphite. You can pause the video, attempt the solution of this problem, and then restart the video to see how we solved it. Welcome back. To continue our solution, we need two facts. The first of this is the delta G naught of formation for diamond. And we can consult the back of our textbook, and we find that this has a value of 2.8 kilojoules per mole. Similarly, if we look up the delta G naught of formation for graphite, we find a value of 0. Now, it is not a surprise that the value is 0. By definition, delta G naught of formations for elements in their standard states will be 0. And since graphite is the standard state for carbon, it is 0. And we notice that diamond is not the standard state of carbon, since it has a non-zero delta G naught of formation. Now we can calculate the delta G naught of reaction by utilizing the fact that delta G is a state function. So this particular value is delta G naught of products minus delta G naught of reactants. Now, we notice that the product of our reaction is graphite, and its delta G naught of formation is 0. Our reactant is diamond, and its delta G naught of formation is 2.8 kilojoules per mole. So we subtract 2.8 kilojoules per mole. And this gives us immediately that the delta G naught of reaction is minus 2.8 kilojoules per mole. And because the delta G naught of reaction is negative, that tells us that equilibrium favors products. Next, to calculate the equilibrium constant K, we are going to employ the relationship that K is equal to e to the minus delta G naught divided by RT. So let's first calculate the delta G naught over RT part. And we've already determined that delta G naught for this reaction is going to be minus 2.8 kilojoules per mole. So 2.8 kilojoules is 2,800 joules per mole. And if you have a minus sign in front and the delta G naught was minus, that gives us a positive for the numerator. If we multiply the gas constant R, 8.3144 joules per Kelvin mole, times 298.15 Kelvin, which is our 25 degrees centigrade, that gives a denominator of 2,477.6 joules per mole. Continuing, we get that this particular expression is equal to 1.13. Now notice that whenever we have to perform a mathematical calculation where we have an exponent of some sort, the exponent itself has to be unitless, because it doesn't make any sense to raise e to the power that includes units. So this has to be a unitless number. So if we continue with that, the equilibrium constant K is equal to E, and we know what the exponent here is 1.13. So this gives us that the equilibrium constant is 30.96. So as we could have predicted from noting the sign of delta G naught, since the equilibrium constant is much greater than 1, being 30.96, this tells us that the reaction of diamond going to graphite at equilibrium overwhelmingly favors the products graphite over the reactant diamond. This doesn't tell us, however, how quickly it takes for this reaction to reach equilibrium, and the long-term stability of diamonds in jewelry depends upon the fact that this particular reaction approaches equilibrium very, very slowly. I thank you very much for your attention. Have a good one.